Hello and welcome to our YouTube channel. So my name is Ali Traoré Dubuis. I am a PhD student here at CSIC, which is a research center in Madrid in Spain, and I am a fellow of the Marie Curie training program in Europe called ARGENT, which stands for Advanced Radiotherapy Generated by Exploiting Nanoprocesses and Technologies. So I'm going to give you first the flavor about my research project as planned today. So this is the theoretical part. We will see next year as the practice, in fact. So the goal of my research series is to study and understand how by electron I mean secondary electrons, which are low energy, interact with molecules present in human body, from the macroscopic level to the nanoscopic level, and this is the so-called top-down approach. So the main idea here is to redefine the concept of absorbed dose in current radiotherapy practice. In radiotherapy, currently the absorbed dose is the dose which is left by the radiation in the medium after ionization, and this is the so-called absorbed dose in unit grays. However, recently, from studies like Leonsange, it has been shown that secondary electrons, mainly responsible for the deposited dose, can break molecules, and more precisely biomolecules, at excitation level of energy, even under these ionization energy levels. For example, if you take the DNA under the ionization energy of the DNA, which is 8 eV, this DNA can be damaged. So this concept of absorbed dose needs to be redefined. In order to achieve this goal, our plan during this PhD and the next years is to perform both experimental and theoretical studies. So the experimental part will involve studies of the interaction between secondary electrons from high energy photons, which are produced by the linear accelerator in radiotherapy center. This is the LINAC, which is called LINAC or linear accelerator. And we will study the interaction of these photons produced by the LINAC and the water molecules, which is the main constituent of the human body or living cell. And later we will study this interaction with biomolecules, more complex. The theoretical part has to do with the improvement of the Monte Carlo code-based treatment planning by including the radiation damage induced by those low-energy secondary electrons, and the latter code is termed the low-energy particle track simulation, and I will work on its validation under clinical conditions. So furthermore, we plan to study how and why nanoparticles are effective in tumor irradiation based on their physical chemistry. So one last point before ending the presentation of this research project is to make it clear that this research is not, although I would like to, but it's not aiming at treating and finding the solution for cancer, but at improving the quality of the treatment by sparing the normal tissue and targeting more effectively the tumor itself. So later on about this channel, I will provide some basic information about the equipment used in physics lab, and some theory about my research project in this YouTube channel. And this information will be provided in French, simply because this will be benefit people from who are speaking French, and I'm French also. I was born in France, and so my other colleagues will provide it sometime overlapping information in other languages, so we can target population which are broader. Okay, thank you for the attention, and we hope to see you in other lectures. Thank you.